Good morning, everyone. I don't know, where is everybody so far?
I don't know, I reminded on the Slack also.
Yes, I noticed. Thank you. Where's Roy? Oh, where's Rich?
I messaged him also. I just
Strange.
wanted to see if they remember they are coming
Roy's
today.
here. Strange.
At least Mac is here, right? Mac, are you presenting today?
I wanted to make one announcement, but I guess I was hoping everybody is there. But yes, I think I'll make the announcement in the end. And I think Mac, I think go ahead since it's recorded, so it's fine. People can watch it later. Yes, we're running out of time now.
Cool.
I've already given you access, so you should be good.
Okay. I think my team is going to give an update on our progress and what we hope to do for the last week.
Mm-hmm.
Let me show you my screen. So for my part, this is my notebook. You can see this, correct?
Yep.
Great. These are my choices. Well, let me start with the end and show you my results, and then I'll tell you what I did. I'm getting a validation score using Salmon's pipeline. I'm getting a validation score of about 40. I also submit to Kaggle, and that score goes with about a 30 Kaggle score. These are all Kaggle scores. It's kind of a log I'm keeping.
Mm-hmm.
The best
Nice.
Kaggle score I can get is about 30, 31. I can't do anything to break below 30 or so.
I'm just curious, how much is their rating system goes? If it's 30 out of, what's the range, out of 100, or what is it?
It's RMSE, and the winner of the Kaggle was about 17.8.
Oh, okay.
This score puts me around 330th place.
Nice. You tried. Thanks for sharing.
So my choices up here for the pipeline, I used target guided ordinal encoding. I thought this is a pretty clever algorithm from the Spaniard's class. This lady. This algorithm takes the categorical variables and takes the average of each. Is the building, the facility type, is the average of each with respect to the target, side EUI.
I guess x-axis needs to be fixed. X-axis. Mm-hmm.
I'm sorry?
X-axis can get fixed, I guess.
Yes.
Mm-hmm.
Yeah, you can just rotate them 90 degrees.
Yes.
Yeah.
That's okay. Okay.
This okay, so this is the encoding. It reorders, it encodes and reorders the categorical labels with respect to site EUI to make it easier for the tree to navigate. Use arbitrary value imputation for the three columns with nulls. That simply put a value of -1 in those spots where there were nulls. And my VIF, I used VIF to look at which columns to keep, and then I just started cutting columns out based on the feature importance graph and the RMSE score that I kind of tracked pretty closely with each change I made. But like I said, I can't get below about 30. Outlier detection. Diana gave us 2 different outlier detectors. This is the second one, the one that she knows a little more about and she uses more. It's kind of interesting. It uses a random forest to detect outliers. You can set the amount of outliers.
Why did you choose that person? Is there any particular reason?
Why did I choose?
You were saying Soledad something. It was a lady, I'm assuming, right?
Kelly's.
Actually, this was sorry, this target guided ordinal encoding. This was provided from this lady, Soledad Gali.
Okay.
She's a Spaniard who has a class on Udemy called Feature Engineering for Machine Learning.
I
She
guess
has
with Diana and you were referring about it a few weeks ago. I guess that's the one I'm assuming.
Yeah, and this
Yes.
is from that. Yeah.
Mhm.
Diana suggested isolation forest for outlier detection. She
Okay.
also suggested a different library called PyOD.
Yes.
But this one is clever because it will take into account the entire feature set. It uses random forest to detect this amount of outliers, and then you can drop them from your.
So PyOD, if I'm not mistaken, that was also for outlier detection, and this is also as well.
Yeah, and she basically dropped PyOD because it seems like it's only gonna take into account one feature,
Oh,
and that's what she uploaded in that one notebook. She uploaded the outliers, but only determined with one feature and the target.
okay, that's a drawback.
Isolation forest will take into account every column, and you can set the number of the amount of outliers to find. They come
What
out
does
as
0.001 means? Like, what's the optimal range for that? I guess I need to study for this particular one. I don't know about isolation forest.
well. The documentation just suggests you use under 5%.
Okay.
I tried a range of values from half of this to about 5%, and I found very marginal improvement for this value, and it got significantly worse for just about everything else.
Okay, good to know.
So it's not improved by removing outliers, at least for my pipeline here.
That's okay.
This is about 1% or 1,000th, 10th of a percent, I guess, of the train, and so all you do is you put back you paste together your
So
sets.
0.001 is like a 0.1%
Yeah,
contamination. Okay.
yeah,
What's the
So-
highest you tried?
5%.
Okay, you tried. Okay, and nothing was improved. Okay, that's fine.
So I pasted together my labels with the data. I dropped anything that here's where I keep only inliers. One is inlier, -1 is outlier. So I drop all the outliers here, and then it's just reformatting the data sets back to how they were initially before pasting together. I got to some of Rich's code for hyperparameter optimization, but I can't really figure out how this works. It seems to just cause overfitting. I eventually gave up on the optimization code and went to kind of manually tweaking settings, but I also couldn't find a single one, not even an estimators that would improve it, which seemed kind of odd. But I ended up just using purely defaults, and that's where I'm at. Here's some visual inspection and feature importance with just the 7 columns I'm using, and that's where I'm at.
What this chart is showing, I don't know the axes.
These are examples. These are the first 200 predictions that my model makes. My predictions are in orange.
Oh, okay, it's his prediction. Okay.
It's just a bit interesting to compare like the peaks and where I'm trying to capture outliers, and then here to look at how I'm trying to capture noise. But yeah, it's
if you can label axes, I think that would be helpful.
okay.
Yeah, that's my fault that I didn't put the axis in the code because I was just doing it personally. So it's not Mac's fault; it's mine.
I know it was for you guys. I'm assuming on backend you guys are doing more quick and dirty just to see what works or how it looks. I guess I know the formal version we'll see on next week, I assume. Okay, that's fine. What else?
So that's my pipeline, and I think Divya has something to present as well.
Okay, good.
Yeah, I can show my screen. Can you see my screen?
Yes.
Yep.
Okay. Actually, for feature engineering part, I have used the feature engine library, and I have used these functions. Basically, I have actually dropped the constant features. The constant features means the features same value is repeated for a like 99% of data is one in this days above 110 Fahrenheit. So that's why I'm dropping this value. So basically, it drops um, the features that has same value repeated more number of times. And then I use the drop correlation feature, which uses the Pearson correlation method to find the correlated features. It will group the correlated features, and then it will take only one feature from this correlated features. It will skip all the other features. And then I used a custom transformer for just converting the years column into age. And this one, same as the correlation selection that I said before, but here it will select the variable based on variance. If it's, it will take the feature that has high variance from this data, and it will drop all the other correlated features. So after that, I aggregated the values into seasonal columns like winter, spring, summer, and fall. For that also, I use the same library. And then, yeah, then I did the arbitrary imputation. I actually used the minus 999 for all the missing values, because it looks like if we put some bigger value than the other numbers, then actually the machine learning algorithms will treat that value by itself better than imputing, it seems. So I wanted to try the arbitrary number as a big one, or so I tried a minus 999. And I have used the ordinal encoding. I tried
Why minus 19? Why did you try any higher number? Or
yeah,
I guess
it's like we can try plus 99 or minus 99. I just wanted it to be unique. It should be different from whatever values that is present in our data set. So just I tried some low value. Here I tried low value. So I tried one hot encoding and ordinal encoder as well. So ordinal encoder gave me pretty good results. When I use one hot encoding, I got a score of around 50, and now it's 40. So I think ordinal encoding is working better with mine. And for outlier, I did not remove any outlier, but I used outlier capping method. In this method, I use the IQR method to find the outliers. And I use it for capping the values. Like I'm not removing any values, but just capping the values to based on the IQR. So the fold is 1.5. So 1.5 times the IQR value. And I'm applying that to these three columns only. And then this is the pipeline.
Divya, what is meaning of capping here? If you're not removing
capping, like I'm not removing the outliers that are present in the data set. I'm just capping it with some value.
Yeah. So on the left and on the right, it will cap with a particular value.
Yeah, that's
and
right.
that method is obtained from the capping method IQR. So
yeah, that's correct.
this is a good library actually, feature engine. I've used it before. A lot of very nice things.
Okay, this is the first time I'm using, and yeah, I found it's useful.
Which Windsorizer?
Windsorizer. Yeah. No, the library is feature engine, he's saying.
Under feature engineering.
It has all the imputation methods and feature engineering and all those stuffs. They have lots of functions available.
So in place of outlier, you said you put that IQR?
Yeah, IQR method.
Okay.
Yeah. Because our data is not standardized, right? It's skewed towards the right. That's why I chose IQR, and I did not use uniform method. there is a uniform method as well, which uses the
Hmm.
standard deviation for removing or capping the outlier. They have the method for removing outliers as well, but I used capping just to check how it works. But I did not try the removing, but I'll try it later on. And yeah, this is the pipeline. And I'll go to the, I have used a cross validation set. I did not use a separate validation set, but in cross validation, actually, I tried the 3 algorithms, like I tried linear regression, decision tree, and random forest. When I did the cross validation, I picked the 10 sets. So it will actually take a validation set and it will compare it with the validation 10 different validation sets. So after that, it averages it to a value. So the average mean square root mean square value that I got is 51 for the linear regression. So when I see the linear regression model, the RMSE value for the training set and the validation set both are almost the same, which means it's not overfitting. But since the train set error itself is very high, I think the model is not enough to predict the pattern in the data set. So I think it's better to go with a complicated model. So I went with the decision tree model. But when I tried decision tree, it's obviously overfitting and it's trying to memorize all the data. And so I got 0 for the as a training error. And then when I tried validation, it's 55. So the margin is very high. So obviously it's overfitting. And to reduce overfitting, we can go for the random forest, because since it's using a lot of trees, it reduces the overfitting. So for this, the training set error is 14 and the validation error is around 41. Here the value is better, but still I think it's overfitting. So I wanted to play with some hyperparameter tuning, and I used the grid search as well as the random search. For grid search, I actually used maximum features and n estimators. I tweaked those 2 parameters, and bootstrapping as well. So bootstrapping means the method the Salman taught in the other class, right? The bagging method. If bootstrap is true, then it's using the bagging method, and otherwise it's using pasting method, which means it's replacing the samples if it's using the bagging method. And yeah, these are the scores, and the best score that I got is I think, let me show here. Yeah, I tried for some more values as well, and yeah, I think the best score is 43, around 43. And I tried it for the train set value is 37. Now the value is increased, but when I compared it with the validation set, it's not, the difference is not so much. So that means the model is not overfitting, but the performance is not that pretty good. But we can, I think we can tweak around, and we can try a few more models as well. So I tried the XGBoost as well. This uses the boosting algorithm. So with this also, I tried the random search for hyperparameter tuning. And finally, I got, for this one, I got just one error reduced to by 1, like 42. Validation set, I got 42. And training set, it's 37. And test set, it is 41. So yeah, this one is not overfitting, but still, I think the problem is with the feature engineering. Maybe if we take some other features or something, we might get a better result. That's what my understanding is. And do you want me to present Diana's work as well?
Sure, if you're comfortable.
Yeah. Okay, she used the feature engine as well, and then she used Teapot. Teapot is an automated ML, so it will run on a lot of machine learning pipelines, and it will give the better results. So yeah, these are all the basic things she did. She actually dropped the columns, like a wing feature she dropped manually. And then a temperature, she summed all the columns from January to December, from all the values she summed into one temperature column. And when she checked the correlation, she said it was pretty good compared to the average. So her temperature sum values correlation is better than the average temperature. So that's why she kept the temperature sum value.
Temperature average of entire year?
Yeah.
Hmm.
She actually added everything,
Okay.
all the temperature columns. Yeah. And then she did the ordinal encoding. And this is the values that the ordinal encoder assigned for the categories. Then she used the KNN imputation for missing values. And she used variance inflation factor for reducing the columns. Like she actually dropped the sorry. Yeah, here she dropped the average temperature since it has a high VIF score. So she's taking all the other things into consideration. Yeah, that is what she did for feature engineering. And then for outlier detection, as Max said, she used the isolation forest method, and she used the contamination score of 0.03. Yes, the contamination score, we can predefine it and we can play with that. And for her, the outliers number is 1819. She's dropping all those values. Yeah, after removing the outlier, she just plotted it to show the values. And then she used the teapot library to find out the a good machine learning algorithm. But looks like she ran it for two hours or something. But it needs more time, like 36 hours or something, to find out all the pipelines, machine learning pipelines. So the result wasn't actually good. But that she is not sure whether it is because it has not tried all the ML pipelines, right? So that may be the problem, or there may be problem with some internal CV score. She is working on that. Maybe if she can find a better one, she will update it by Thursday, it seems. So yeah, and she plotted the feature importance, like facilitator type. These are the features that has a lot of importance, and her temperature sum, it is the least important from the features that she has. Yeah, and then she did use the Salman's pipeline as well. And for that, she got like around 46 RMC value. Yeah, that's it. And Shapely, it's for just explainability. She used that library to show the features that has high importance. So she basically put a graph for showing the importance, energy rating as the highest feature importance, and she plotted this as well. Yeah, that is it.
Wow, nice.
Thank you.
Okay. Interesting.
Couple of cool methods in there that I don't think I've tried before, and it looks like it brings back some interesting results. But I think across the board, it looks like every time people are running the various different methods to find the most important features, we're ended up at the same with the same ones over and over again. So, you know, I think that's something to take forward, you know, and especially, Mac, the part where you compared some of the results to the Kaggle competitions. You know, that is quite interesting. It seems that we are around the same sort of mark as what is going on in the Kaggle competitions. But I think in our team meeting, Michael brought up quite a good point, is that we're estimating the site EUI, and it's, you know, it's a continuous number, and the site EUI will be the sort of final decision maker on whether a building or not will be retrofitted. And because it is the site EUI is a calculation in itself, being, you know, 5% away from the actual value that we predict, you know, if it's, you know, if we've got like a prediction of 300, being 15 off isn't necessarily going to make a massive impact in terms of that decision whether to retrofit or not. So, you know, I understand some of the scores, you know, 30s and stuff. There is room for improvement, but in a real life situation, it wouldn't be that bad in terms of making that decision of whether a building or not is being retrofitted. So I think what we've done as a group and what you've done as a team and what has been presented today is, you know, it's a good solid model, but, you know, the route to a good model is always through bad models. So there's always room for improvement and improvement. So what you've done is fantastic. And the scores that we're getting, they're really strong. So yeah, well done. Well done, everyone on your team.
Thank you.
Yeah, good job, guys. So it looks like then, I guess, I'm glad that Mac went till the end and then submitted on Kaggle, because we are under the impression the deadline has passed. So we are not even bothering. So that's good.
I checked the Kaggle out a couple of weeks ago, and a lot of the techniques people have used on Kaggle are not, you know, they're either exactly the same of what we've done or not far off. So, you know, when I checked against that, I was thinking, yeah, we are on the right track as teams as well. Each individual team, you know, I've had a little nose of what people have been doing. Yeah, we're all on the right track, and there isn't any sort of massive difference between what people have done on Kaggle and we've done. So yeah, I'm happy.
So it just confirms that we are also in a right way, actually, not just completed.
Yeah.
Sweet.
Yeah.
Any other thing anybody to add here? Okay, well, if not, there are a few things I have to cover before we wrap up. So starting, yes. Sorry about that. So next week will be our final week, right? And in that one, let me post something very quick. That's where we are. Today is 27th. Most of the teams are done on model development evaluation stage. Now that's a deployment phase. That's as we expected. So on 3rd August is our last day. So for this final week, there's only an exception. There will be, rather than our regular meeting on Sunday and Wednesday, there will be three meetings. So team 1, which is Rich's team, will present us model deployment and some of the presentation of what they've covered on coming Friday, which is 29th of July. Then team Salman and team Royce will present on 31st July, and the final presentation will be from team Mac on August 3rd, and that's where we'll conclude this project. So that's just one update. And also, thanks for presenting good stuff today. And one thing I would like to give a reminder to all the leads, co-leads especially, or all the presenters. When you explain, always assume the people around you are beginners, which in real there are actually most of the participants in this group. So sometimes this breakdown, especially some of the new algorithms which you introduced, so that might help them. So that just I wanted to remind. And also, I know you guys are meeting within your own teams in separate times. I cannot make it compulsory, but would be great since some of the stuff which you guys discuss, it's also quite valuable. Others, I assume, would like to know as well. And of course, because of we all over the place and globally, so we time difference, it makes it's quite difficult to attend all meetings. So it would be great if you guys can post your meeting recordings. I created a sub themes as method part and section in Notion. So if you can post it over there, they'll be helpful as well. And also, we already talked about the references thing, so leads know already about it. And that's pretty much it on my agenda. Anything else somebody want to add?
Yeah, we'll be sharing the template for the slides that we talked in the leads meeting. So I think leads can communicate much better how they want to divide and all, right?
Yes.
About the final presentation.
Yes, we talked about it already, so they should know. But yes, we can share something if they need more help. But yes, sure. Yes, thanks, Omar. Good point. Anything else, anyone? Okay, if not, then I guess we are good, and I'll see you guys on.
What time is the meeting on Friday?
Our timing is always the same, 9 a.m.
Okay. EST.
Right? EST, yes.
Okay.
Eastern Standard Time. Okay, guys, have a good day.
Thank you. Bye.
Have a good one.
Bye,
See you
everyone.
soon.
Thank you.
Bye-bye.
Bye.